Hey guys, how's it going? This is Miss Perry. We are going to finish up section 10.3, and this is the last little bit at the end of it on circular motion and friction. Now, circular motion is when an object rotates around an axis. So if you're swinging a ball around on a string, or a car is going around a curve, an ice skater is spinning, things like that. That's circular motion. A revolution is completing one trip around a circle, and then the distance of one revolution around the circle is called circumference. And the time it takes for one revolution around the circle is called the period. It's a time period. Okay, so an example I like to use is a merry-go-round. It moves faster on the edge than in the middle because the radius is greater. And I have a video for you to watch that explains that. I don't know why it's doing all that, but I have the link below, and then I think I have the link on your assignments as well. So go ahead and watch the Hewitt drew it, and he tells you all about circular motion. Now, we're not going to be doing the math on that, but just take a look and see how he explains it. Okay, so acceleration occurs because the velocity's direction is changing. So anytime that you're changing direction, you're accelerating. But this is called centripetal acceleration. And the acceleration is toward the center of the circle. You have to have force to accelerate, so this is called centripetal force. And centripetal force also means center seeking. Force is always toward the center of the circle. And an example, you might think about clothes in a dryer. The clothes are pushing out, but the metal in the dryer drum is actually pushing in. So that's the centripetal force, is pushing in and holding the clothes in the dryer. Also, a car around the curve. If there's no friction on the edge of the road, the car is just going to keep going. So it's actually pushing the car toward the center. I know this is kind of weird to think about, but remember we talked about forces are in two directions. So if you have force one way, then you have opposite force as well. If there's no force, then no acceleration occurs. So if you don't have any forces on something, remember we talked about you have to have a force to move an object, or to stop an object, or to turn an object. So you cannot have any acceleration without force. All right, friction is the resistance of motion, and it depends on the weight of an object and the nature of the surfaces. So there's two parts to this friction. You have attraction, and that's where the molecules on the surfaces attract to each other and form temporary bonds. And that's like if you put tape on a sheet of paper, they're attracting to each other. Okay, repulsion has to do with the microscopic irregularities on the surface. So like if you put sandpaper against a wooden surface, they're going to repel each other. They don't want to be together. There's types of friction. You have kinetic friction, and that's also called sliding friction. And it occurs when two surfaces are sliding across each other. And then static friction affects objects that aren't moving. So if you have a big heavy piece of furniture you're trying to move, you can't move it because you have so much friction that it cannot be overcome by the force that you're giving it. Okay, there's also rolling friction, and that occurs with objects that are rolling. Imagine that. Okay, and the friction is between the wheels and the surface of the road. Okay, so this was really short. I just want to catch you up on the little bit that's at the end of 10.3. And I want you to go ahead and watch that video. It'll help you a lot with centripetal force. We are not going to be doing any of the math in this part, so don't worry about that, but I do want you to know the concepts. Okay, take care, everybody. Bye.